So when you're talking about summations, there's this thing where it's like, if your brain works in math, you're like, oh, like I totally get summations, but for loops are super confusing. But if you're really into programming, you can be like, I totally get for loops, but I have no idea what these stupid summations are. So I wanted to kind of put together a little video to show you how to, I guess, translate between them and show you how they're related. So let's start with some vectors. A, which is like A1, A2, A3, B, B1, B2, B3. Now it could go all the way to like A73 or whatever, as long as they're both the same length, and that's kind of what we're playing around with. So the idea is, like in math, you might have something that looks like this. It'll say, okay, the summation of I less than, not lie, 1 less than or equal to j, comma, k less than or equal to 3, a sub j, b sub k. Okay, so when you're looking at this, it's important that you understand how to interpret what this duty bottle thing is here. It's basically saying that it's all combinations of j and k. So it's a little hard for me because I think for loops make a lot of sense, and math makes a lot of sense too, but in this particular case, I hate looking at it this way because it's basically, I guess another way you could maybe write it was to say like, okay, so j can go between 1 and 3, and then k can go between 1 and 3 at the same time. But really it means that I could be like 1, 1, 1, 2, 1, 3, and then 2, 1, 2, 2, 2, 3, and then 3, 1, 3, 2, 3, 3. Of these subscripts where j and k are each one of those values. So when you see something like that, I'll just go ahead and write it out. It's basically kind of like I said, it could be A1, B1 plus A1, B2 plus A1, B3. And then you do the exact same thing again with what's-he-do's-its, with A2. So it'd be like A2, B1 plus A2, B2 plus A3, B3. And then you're like, okay, A3, B1 plus A3, B2 plus A3, B3. Okay, now what's kind of funny is if you look at these, each one of these sections, like say I just kind of grouped them like that, I could rewrite this top one as factoring out an A1, and then it'd be B1, B2, B3. And then if I factored out over here, it'd be A2 times B1 plus B2 plus B3. And then if I factored out A3 out of this one, it'd be B1, that's supposed to be B, 1 plus B2 plus B3, right? So if I was going to take this summation, I could also factor out, so it's like A apples plus A2 apples plus A3 apples is A1 plus A2 plus A3 apples. So it'd just be A1 plus A2 plus A3 times the quantity B1 plus B2 plus B3. Okay, and this is important. I know it might not seem like it, but this is actually important because in programming, the order in which you add things together can make a difference if you're working with stuff where you're kind of working on the edge of the precision of the machine. So, and I'll have another video that kind of goes into that a little bit, but understanding different ways to code the same thing can make a huge difference in the efficiency of your code. I mean, obviously not on a 3x3 or a 1x3 and a 1x3, but if you had a 10 billion by 1 and a 10 billion by 1, then obviously if you can save a little bit of time by doing something in a specific way, you could also think about the fact that you're saving calculations doing it the second way. Because here you have one flop, so floating point operation. So you're doing multiplication, a division, an addition, or a subtraction. So you have one. Let's see, I'll just count them here. So you have a multiplication, addition, multiplication, addition. So that's 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So you need 17 things. You got to do 17 things to make that work. And here you have 1, 2, 3, 4, and then 5. Basically. And there's, I mean, you can get into arguments about how to count floating point operations, but like way less steps here. And so potentially less opportunities to lose precision in the itty bitty parts of the computer that are weird. Basically one way, if you know what's going on with summations, sometimes you can rewrite them in a way that's actually a little bit faster. Another way that I can write this. So even if I wanted to put this in a for loop, so this is how I would do it as a math person. Now, if I'm going to put this in a for loop, I got to kind of think about what that is. I'm going to just kind of do a little bit of pseudocode. So basically I can say, all right, so J is going to go 1 to 3. Actually, let me just write it like this so it's less MATLAB-y. I know you guys love MATLAB, and I do too, but we'll just do it this way. For J going from 1 to 3, and then for K going from 1 to 3, then you're going to have some kind of sum X would be equal to the previous value of X plus A at J plus, or times B at K, and anytime that you're adding stuff in a for loop like this, you always want to make sure you're initializing your value to 0. So you would kind of have something like this, where you go like this. Okay, so this would give you the exact same thing, but this is something I can actually tell a computer how to do. This, maybe I can't tell a computer how to do. I mean, I could tell it how to do this if I knew in advance that's what I wanted to do. So how shall I say this? I want you to know, so if your brain is like, I don't get summations, the important takeaway here is that this thing here means the exact same thing as this thing here. Those two mean the exact same thing. Okay, now let's see if we can translate this into MATLAB speak. Or some kind of programming speak. So mathematically, what we're doing in that second one is we're summing for J going from 1 to 3, and then of A sub J, and then we are also going for K going from 1 to 3. Derps, derps. That's not very pretty. Of B sub K. Now, I'll talk about that in a second. I'll make this pretty though. All right, so we can do that as well. So the way that we have this written here in light blue is the same thing as this mathematically, but all of these mean the same thing is kind of where I'm going with this. So anyway, so these would be two separate loops instead of a whole loop. And there's a couple of ways you can set it up. You could kind of set up one loop where you say, okay, so I'm going to start with X is equal to, well, I guess if I'm summing things, I need to add things to 0. I don't know why I started with that. Add things to 0. So I'm going to go for J going from 1 to 3. X is going to be the previous value of X plus the new AJ. And that would take care of that first one. And then I could say, if I wanted to, I could create another variable. There could be a couple of reasons I might want to do it that way. So I've got for K going from 1 to 3. I could say Y is equal to Y plus the new B sub K. And then at the end, my answer would be X times Y, like that. And so that's how we would program this up. And again, it's kind of, a lot of this stuff doesn't matter if you're doing boring stuff. Like if I have vectors that are like X's or A is equal to, 3, or apparently 1, 3, and 5, and the B is equal to 7, 9, and 12. It doesn't really matter what order I add these together. But computationally, I can create scenarios where doing things these different ways would get you completely different answers. So what's also neat is that you might have noticed is that it really wouldn't matter if I called this one J and this one K, but I could actually rename this one over here. There's really no reason I couldn't just call this K. Because K, because I just had it as K. There's no reason that I couldn't rename this as J, because J would be being reused, because once I get here, I'm done using J. So I could use it again. And again, there might be a reason that I'd want to do that, but I just want to make sure you guys understand there's no reason that I have to use the letter J for one and I have to use the letter K for another. It's really just that, like, once I'm done with using the J, I could do that. Like over here, I couldn't switch or replace the J with the K because it's being used at the same time. So that would be really important to have. So just to kind of sum up, a couple of different ways to write this is just kind of as a programmer, it's important to understand. So this is a lot of these videos I'm making are for discrete math. And the reason that programmers take discrete math is so that they know how to do things more smartly, I guess. But I guess what I was getting, so having this ability is going to make you a better programmer in the end, is where I'm going with this. All right, so since J and K are independent, I guess some other ways that we could write this, we could say, okay, so for K is an element of K. So like all the Ks. So in our case, K would be the set 1, 2, and 3. Okay, so this is like a little k. Let me try and zoom in so you can see my really, really, really good handwriting. So K would be an element of the big set K. So for any K in the big set K, and any J that is an element of the big set J, and again, the big set J would be 1, 2, and 3. This is just a fancy math way of saying it. Then I could do the summation A sub J and B sub K. And me, I like this a little bit better than this because I always have to look at that and go, wait a second, what are you actually asking here? So the reason mathematicians take discrete math is so that they can talk to computer science people. And don't give them stuff that looks like this because nobody except you knows what this means, okay? So there's that. I can write things like that. This is also, I could say, is equivalent to J going from 1 to 3. And then K going from 1 to 3, A sub J, B sub K. Now, this is the way mathematician peoples, y'all should give this to the computer programmers because then they can look at this and go, oh, for loop, dunny bunnies. Okay, I don't even have to go, wait, what's a set of K and what's a set of J? And wine, math is hard. So if you set things up like this, and even as a math person, I much rather see stuff like this even more than this. This is okay if you've got weird things like, say the set K was like 1, 7, 14. You're only adding the first, the 7th, and the 14th elements together for some stupid reason. Then that would make more sense. But especially if you got something linear, like why are y'all coming up with weird ways and confusing ways to explain things to people? I know it's for job security, but come on now. Now, this is super important. Only because J and K, I keep saying this, are independent. And I write this out, independent. Because J and K are independent, we can switch order. We can switch the order. Only because they're independent. And like if this said is less than K, or if it starts at K or something like that, then it would, well, I guess this one would have to start at J. Then we would say, oh, it's dependent on J, on where it starts or where it stops, so we couldn't switch them. But because they're independent, we can switch the order. So it doesn't really matter if I start at K, and then at J, A sub J, B sub K, I'm going to get the exact same answer. Basically, this second one, this or fourth one or whatever that I just wrote, that would be the equivalent of instead of, my stuff's so messy. Instead of adding this way, and this way, we would be adding them this way, and this way. Because the K would stay constant, and then we change the J. The B would stay constant, and we change the J would stay constant, we change the, you know what I'm saying. It's like adding it in columns instead of adding it in rows. And again, this shouldn't matter except that in really, really big matrices, and depending on what kind of language you're working with, code stores, different programming languages store things in columns, and different programming languages naturally store things in rows. So it's, in these languages here, it's faster to add things by columns because that's how the computer is naturally progressing. Here, if things are stored in rows, and again, none of this matters unless you're doing massive calculations. Okay, so this isn't something that we need to nitpick about. If I have a 3 by 3, no, of course it doesn't matter. It just has to do with how things are stored. Now, granted, these are vectors, so it's not just single element vector, so that's not a huge or single dimensional. Yeah, 1 by n's or whatever. So it's maybe not that big a deal, but I'm just trying to introduce you to the concepts that this is definitely something that you kind of want to have in the back of your mind of like, eventually, like, why is my code so stinking slow? It's like, oh, maybe if I try flipping the order on these, I would get a slightly different answer. And then, of course, as a reminder, we can also, and that's because of how this worked out, is I can rewrite these as two independent sums that would actually be much, 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 much faster than if I was going to be doing, or a lot less floating point operations than if I was going to be doing it like this. So again, programmers, whenever people give you stuff that's weird and it's super slow, see if you can take what they've given you and write it in another way that might be programmatically faster. Math people, stop telling people this because it doesn't make any sense. Tell them how to do things in for loops.